Hello and welcome. We have arrived to Lesson 4, Unit 2, Derivatives. This lesson has been prepared for students who are taking the Calculus and Vectors course MCV4U. And in this lesson, we will explore, discover, and learn how to use the quotient rule. The quotient rule helps us differentiate the ratio of two functions. If two functions, f of x and g of x, are differentiable, which means their derivatives exist, then the quotient is differentiable. And the derivative of the quotient will be f prime, so the derivative of f times g, minus fg prime divided by g squared. In Leibniz notation, we say that d dx of f of x over gx equals gx times the derivative of f of x minus f of x, the derivative of gx divided by gx squared. As always, we are going to start with a proof. So we are going to let f of x over g of x be represented by some function h of x. And our job is to find h prime of x. So for this, we're going to ask the product rule for help. And what we're going to do is we're going to start by expressing f of x as h of x times gx. So we'll differentiate. So we say f prime of x then must equal h prime x times gx, that's product rule, plus g prime x times h of x. Now remember that we are trying to solve for h prime, so this is our unknown. So our focus will be isolating h prime x. So we're going to take this term to the other side, and we'll say that f prime x minus g prime x times h of x equals h prime x g of x. Divide both sides by gx, and we'll have h prime x, so I'm also reversing the sides, would equal f prime x minus g prime x times h of x divided by gx. Okay, so h prime x equals, so big fraction line here, we'll substitute h of x minus g prime x. So we'll substitute g prime of x with f of x over g of x, because that's what it equals, right? So we're substituting h of x with f of x over gx, because that's what it equals according to our equation. And that's going to be over gx. So we'll simplify. And this would leave us with, now remember that here we have a multiplication, right, of two fractions. But then we also need these terms to join each other. Denominator here is 1, which means that we need to multiply by gx, both numerator and denominator. So that would leave us with gx f prime x minus g prime x f of x, and all this will be over gx. And everything again over g of x, okay? So remember that we have this big fraction in here as well, which continues to stay right here. I'm just highlighting it so that we won't mix it up with the fraction above it. Now remember that this is a division by another fraction, gx over 1, or we can look at it this way. So h prime x equals I'm going to write the numerator first. I'm writing the numerator first here, gx f prime x minus g prime x f of x divided by gx, and then multiplied by 1 over gx. So multiply together and we get h prime x equals, and one thing that I like to do is start with f prime, meaning that instead of writing gx f prime x, I'm going to start with f prime x gx, and then minus g prime x f of x, and the two gx's will multiply each other to leave us with gx to the power of 2. And that would equal the derivative of f of x over gx. Okay, so this is the quotient rule. So the derivative of the ratio of two functions. Okay, so now we're going to take a look at some examples. So example number 1, we're differentiating f of x equals x squared plus 2x minus 3 over x cubed plus 1. So this on top here will be our f of x. At the bottom, we have g of x. So we're going to say that f prime x equals, long fraction, the derivative of x squared plus 2x minus 3 times x cubed plus 1, and then minus the derivative of x cubed plus 1 times x squared plus 2x minus 3. And this will be over x cubed plus 1 to the power of 2. Now, I haven't done much in here. I've simply written out or applied the formula. Normally, you would just simply start differentiating the numerator, multiply by the denominator, and then minus differentiate the denominator, multiply by the numerator. But this is just the first day of learning this. I'm learning or applying the quotient rule. So that's why I'm showing all the steps here. So what we have is x squared plus 2x, that's 2x plus 2, times x cubed plus 1, minus derivative of x cubed plus 1 is 3x squared, x squared plus 2x minus 3. And this would be x cubed plus 1 squared equals. Now we have to expand and simplify, and as we have mentioned in the past, like differentiating has a lot of algebra, so algebra will always be on the way. We just have to embrace it and be prepared for it and ready. So 2x to the 4 plus 2x plus 2x cubed plus 2 minus 3x4 minus 6x cubed plus 9x squared. Very easy to miss terms, okay? So stay focused and always double check. So again, we have like terms in here that we are about to group. So 2x4 and negative 3x4, that will give negative x to the power of 4. Let's look at the x cubes. So for x cubes, we have a 2x to the power of 3 and a negative 6x to the power of 3. So 2 minus 6, that's negative 4x to the power of 3, lots of negatives. And we have 9x squared all by itself. We have 2x and then plus 2. Down in the denominator, we have x squared plus 1 to the power of 2. So that's an x in here. And this is the final answer. Let's move on to another example. Again, try to do the next example on your own, always. Okay, and then you can follow along with the video after. So here we go. we have to find dy dx of this function. Now, as we've mentioned before, it's very important whenever you have radical terms, convert them into powers. So rewrite this equation in the form x to the power of 1/2 over 1 plus 2x. And you know what? Even the denominator, rewrite it as 2x plus 1 so that you have the terms listed from highest to lowest degree. So dy dx equals the derivative of x to the power 1 over 2. So I'm going to continue doing this for a couple of examples. So times the function 2x plus 1, and then minus the derivative of 2x plus 1 times x to the power of 1/2. And all this will be over 2x plus 1 to the power of 2. All right, long line again. And the derivative of x to the 1 over 2 is 1/2 of x to the power of 1 over 2, take away 1, so that's -1/2, times 2x plus 1. Then the derivative of 2x plus 1 is just 2x to the power of 1/2 over 2x plus 1 to the power of 2. Now, one very important thing that we actually usually focus on when we differentiate functions is we try to write the final answer in the most simplified and factored form. So you will see that very often. So write the answer in the most simplified and factored form. Okay, so what we're going to do is now factor the powers that are in rational form. That is very important. So what we're going to do is factor the greatest common variable. You see, we have two groups of terms here. So one group would be, so we have this group of terms in here. And then we have this group of terms in here. Now, I want you to look at the variable x and think, what's the greatest common x that they have, okay? So, usually we want to take out the x to the lowest power, okay? Now, another thing, though, that we can do in this case is expand the first group of factors, of factors exactly. So that would be equal to 1/2 times x to the -1 over 2 multiplying 2x and then plus 1/2 x to the -1 over 2 and then minus 2x to the power of 1/2. And that will all be over 2x plus 1 to the power of 2. So 2 and 2 simplifies. X to the -1/2 times x to the power 1 gives x to the power 1/2. And then we have plus 1/2 of x to the -1/2 minus 2x to the power of 1/2. Now, this is all going to be over 2x plus 1 to the power of 2. So, as you can see here, we have like terms. 1x to the power of 1 over 2 and -2. So, therefore, we have minus x to the power of 1/2 plus 1 over 2x to the -1/2 over 2x plus 1 squared. So we're going to take out the greatest common factor. Now remember when we took out, say, for example, 2x squared plus 3x to the power of 5, for example. When we say the greatest common factor, that means that we are taking x to the lowest exponent, because that would be common, right? Now I want you to go back to what we have in here and think, here we have x to the power 1/2, and negative half. What's the lowest power? So the lowest power is negative half. So that's the power we want to take out, okay? Another thing, though, that probably gets your attention here is this number, 1 over 2. Whenever you have a rational coefficient, that has to come out as well. And here we also have a negative sign to start with, so you may take the negative one out. And what you will be left with in the first term is, because you had no coefficient here at all, so you had a coefficient of 1 basically, and you took out 1 over 2, then you're going to give this term a 2. The negative sign is out. And then x, now I want to go back to this example that I was taking in here. And remember that if you take x squared out, then this will be 2 and this would be 3. And then x will be to the power of 5 minus 2, right? Because you have taken a power, 2 powers out, right? It's the number 2 out. So the same applies when we have rational exponents. So x in here will be to the power of 1 over 2. Take away the power that you have already subtracted. And then this would be simply minus 1 because you've taken everything out already. So this would equal negative 1 over 2x to negative half, 2x to the power of 1 minus 1 over 2x plus 1 to the power of 2. Remember, you can simplify those. And we will rewrite the expression now with no fractions inside fractions, right? So we're going to write the negative in front, 1 over 2. X to the power negative half will come to the denominator, become positive. Denominator also has 2x plus 1 squared. And numerator has 2x minus 1. And this will be the answer. Another alternative way of simplifying this would be by going from this step and factoring out x to the negative 1 over 2 right away, okay? So, right here. So I'm going to go over another method of differentiating root of x over 1 plus 2x. And let me know which way you find easier to see and understand. So let me just make this a little longer so we can continue working here. I'm just going to rewrite the equation one more time. So another method of factoring this, slightly different, is by, so I'm going to start from this step here. Okay, so what we had was dy dx equals x to the power 1/2 x to the negative 1 over 2. So I'm borrowing the derivative we found in here. And then times 2x plus 1 minus 2x to the power of half divided by 2x plus 1 squared. Okay, so we're taking this one down here then. And we are trying to factor it. It's already differentiated, right? So we're going to try to factor it slightly differently. And tell me which way you find easier. So what we have in this case is a factor of x to the power of negative 1 over 2. So we have this group of terms, and then we have this group of terms. And the two groups of terms will have in common x to the power of negative half. And the reason why they have x to the power negative half is negative half is the smallest power here, right? So that's what we take out. And we also want to take out 1 over 2 at all times. So let's check and see what we are left with in brackets. So imagine that this doesn't exist anymore because this is all out. So inside brackets, from the first group of terms, we'll have 2x plus 1. And then we have minus. Now remember, we've taken out 1/2. When you take out 1/2, this coefficient will turn into a 4. Why? Normally, when we take out a coefficient, we simply divide the number by the factor we take out. So if you divide number 2 by 1/2, then we get a 4. And then x will be to the power of 1 over 2. Remember, we've taken out a power, and we already discussed what happens there. So that means that we take away negative half, and then 2x plus 1, because it already has a negative half power here, right? So which is multiplying it, so you have to take it away to maintain the value of the term. So this would be 1 over 2, and it's okay when you have 1 over 2, it's okay to rewrite it with 1 in the numerator and 2 in the denominator. Now the x in here is to the power of negative half. Inside brackets we have 2x plus 1 minus 4. Now think of 1 over 2 minus negative 1 over 2. That becomes the power of 1. And obviously we still have 2x plus 1 to the power of 2 here. And further to this, we're going to say that we have 2x plus 1 squared here still. We have the number 2. And we're going to allow x to the negative 1 over 2 to join here. You can write it as a square root as well, doesn't matter. And whatever is left in the numerator gets to be simplified. So 2x minus 4x, that's negative 2x plus 1. And that would be the derivative dy dx. It's the same answer, obviously, but we chose a different way of simplifying it. So what was the difference in simplification process? Here you expand it, right? And you got 1, 2, 3 terms and factored after. Whereas here, you were in factored form for 2 groups, right? And you took out the greatest common factor from each group of factors. Now we're going to move on to example 3. Example 3 has 4 root x over x squared minus 2. Same idea. I will rewrite this function as 4x to the 1/2 and then divided by x squared minus 2. So we're going to say that h prime x equals the derivative of 4x to the 1/2, which is 4, times 1/2 x to the power of half, take away 1, multiplied by x squared minus 2. I think we need a longer line. And then we have minus the derivative of denominator, which is 2x, times the numerator, which is 4x to the power of half, over x squared minus 2 to the power of 2. Okay, that was a bit too long. So now we have h prime x equals, we have a little bit of work to do here. So as you can see, we have 4 and 2s that simplify to positive 2. X will be to the power 1/2 minus 1, that's negative half, times x squared minus 2, and then minus, we have 8, and then we have x to the power of 1 times x to the power of half. So that would be x to the power of 1 plus a half, right? And this is all going to be over x squared minus 2 squared equals. a little bit more simplifying to do in here. So we have 2x to the negative half, x squared minus 2, minus 8x to the power of 3 over 2, over x squared minus 2 to the power 2. Now, remember that we need to take the greatest common factor out. So we have numbers 2 and 8. Common factor, 2. We also have x to the power of negative half, x to the power of 3 over 2. That means that the common factor will be x to the lowest power, which is negative half. So inside brackets, we'll have x squared minus 2, so the other factor. Minus 8 will turn into minus 4. And x to the power of 3 over 2, we have to take away the power we took out. So we took out a power, we give it back, right? And this will be over x squared minus 2 power of 2 equals long line. So we have 2. And by now we know that this x to the power negative half can come down in the denominator and make the exponent positive. X squared minus 2 squared. And now look at the brackets, how nicely they simplify. So we have x squared minus 2 minus 4x. So 3 over 2 minus negative half is 3 over 2 plus half. So a half and 1 1/2 will make a 2. So equals 2. If you want, you can write the x to the power of 1 over 2 with square roots. It looks fancy. And that would be x squared minus 4x squared minus 3x squared minus 2. Now, it would be nice not to have the minus appear in so many spots. So what we can do is we can take the minus out. And then we have 3x squared plus 2. And all this over root of x squared minus 2 squared. This is the factored, most simplified form of function h, or the derivative of h of x. All right, example 3, everyone. Let's move on and see what's waiting for us. So the next example is sort of an application question. So suppose the amount of air in a balloon at any given time is given by this equation. We have to find if the balloon is being filled with air or being drained at 8 seconds. Okay, so remember that if a balloon is being filled with air, it means that the volume is increasing. If the volume is increasing, that means that V prime must be positive. If a balloon is being drained, that means that the volume is decreasing. And if a volume is decreasing, means that V prime is less than 0. Excuse me. So our problem now has become a problem of differentiating the function and studying the derivatives. So we're going to say differentiate Vt and study its sign. So we're going to say that V prime t equals. Now remember, we have radicals in here, and it's always nicer to rewrite the function with powers rather than radicals. So that's 6t to the power of 1/3 over 4t plus 1. Okay, so we're going to say V prime t equals 6 times 1/3 t to the power of 1/3 minus 1 times 4t plus 1 minus derivative of 4t plus 1, which is 4, times 6t to the power of 1/3. And this is all going to be over 4t plus 1 squared. V prime t equals, so we'll simplify a little before we evaluate. Now remember that in here we're not asked to differentiate and express the function in the most simplified and factored form. Okay, we just need to know the value at time equals 8 seconds, but it's always nicer to evaluate. So 6 and 3 will simplify to 2. So then we have t to the power of negative 2 over 3. And then times 4t plus 1. And then we're going to say that the other term is 24 t to the power of 1 over 3 over 4t plus 1 squared. So if you want to know whether the balloon is being drained or filled with air, at time equals 8 seconds, substitute time by 8. So 2 times 8 to the power of negative 2 over 3 times 4 times 8 plus 1 minus 24 times 8 to the power of 1 over 3. And this is all going to be over 4 times 8 plus 1 to the power of 2. Okay, so what we get in here is 2 times 1 over the third root of 8. Because of the negative, this can go in the denominator, and then squared. Multiplied by 32 plus 1, 33, minus 24 times 8 to the power 1 over 3, which is 2. And in the denominator, we'll have 32 plus 1, 33 squared. So you can use a calculator to evaluate this in one step. We're only interested in the sign. Let's see if we are asked to find the rate of change. No, we're not asked to find how fast the balloon is emptied, just the sign of it. So this would be 2 divided by 2 squared, which is 4 times 33, minus 48 divided by 33 squared. So, by the way, 33 squared, here we can simply evaluate that. So, is 1089. So we have no problem with the denominator. It's the numerator that we need to worry about. So that would be 0.5 times 33. Take away 48. Oops, there is a negative number. Divided by 1089. And we'll get the fraction negative 7 over 242 in reduced form. It's less than 0, so we're going to say that the balloon is being drained. Okay, and here are your homework questions. So try to practice every other question as assigned and indicated in your lesson. Okay, so this was a quotient rule, everyone, and I hope you enjoyed the lesson, and I hope you found the explanations useful. Bye for now, and thanks for listening.